Hello friends, today I'm going to solve LeetCode problem number 1011, capacity to ship packages with D days. So in this problem, we are given an array of weights where each element represents the weight of package at that index, and we are also given an integer value days where these represent the number of days in which we have to ship all the packages. And also we are given few constraints. The number one constraint is that I already said that we have to ship all the packages in these number of days, and the second constraint is that we can only ship the package in the order it's given. So we cannot ship the package 2 along with package 8 or package 1 along with package 10. We can only ship package 1, 2, 3 together, or 4, 5, 6, and so on. So now we need to find the minimum capacity of the ship where we could ship all these packages in these many days. So now let's see how we could solve this problem. Let's look at this example here. So our intuition would be that we have these many packages with these weights, right? And what's the maximum weight? 10 is the maximum weight. So since 10 is the maximum weight of a package, which means that the ship should be able to carry this package which is of size 10, right? The ship should also be able to carry the package which is of size 1, but it should be able to carry the package which is of size 10 as well. So it should at least be able to carry the package of size 10, because if it is able to carry the size 10, it would obviously be able to carry the size package of weight 1. Okay, so this would be the least so far that we can assume. Now what could be the maximum weight? Well, the maximum weight, if it were day 1, all of these packages must be shipped in one day, right? So that would mean that all of these, the sum of all of these packages should be the minimum capacity of the ship. So what's the minimum what would be the sum? The sum would be, okay, we have 10, we have 9 plus 1, that would be 10, 8 plus 2, 7 plus 3, 6 plus 4, and the 5 alone. 1, 2, 3, 4, 5, 10. So the total weight would be equals to 55. So the capacity of the ship should be anywhere between 10 and 55, and we know that it won't be 55 because we have 5 days. So what could it actually be? So basically what we are going to do is we are just going to take a middle value between these two capacities. So what is the middle value? Let's calculate it. 55 plus 10 would be 65. So 65, half of 65 is equals to we are just taking the rounded value, so that would be 32. Okay, so we assume that 32 would be the minimum capacity of the ship. Now what we do is we start from the first and we calculate until and unless we reach the size weight, total weight equals to 32. So we are going to add this value. So 2 plus 1 is equals to 3, plus 3 would be 6, plus 4 would be 10, then plus 5 would be 15, plus 6 would be 21, plus 7, 28, and 28 plus 8 would be 36, right? So we stop right here. So we need to ship all of these packages, these many packages, in one day. Now what's are the remaining packages? 8, right? So 8 plus 10 is still less than 32, that would be 16, 17, right? And 17 plus 10 is equals to 27. So these can be shipped in one day. So basically these weights, with this minimum weight, we can ship in only 2 days, right? But we are given 5 days, so we need to utilize all these 5 days. So now what are we going to do is we found a value 32 here, and since the days are less than the days we are given, the value that we found is less, so we are going to shift our right pointer. So now this becomes our right end, and this becomes our left end. So between these two, we are going to the maximum capacity can be 32, minimum can be 10 for the ship. Now we take the middle of these two values. So what would be that? 42 divided by 2 would be 21. So we take the value 21, and then we perform the same operation again with these weights. So what we do is we start from the first weight, 1, we add, then 1 plus 2 plus 3, that's 6, plus 4 is 10, plus 5 is 15, plus 6 is 26, right? So since 26 is greater than 21, so we now found our the total weights that we could ship in one day. Now next we start calculation again, and we do 6 plus 7 is 13 plus 8 is 25. So we stop right here, and then we got the total amount we could ship in one day. Next is 8, and then 8 plus 9 is equals to 17, right? And then 17 plus 1 is 27. So since 27 is greater, we stop here. We got one more day, and this would be shipped in one additional day. So we got a total of 4, and 4 is still less than 5, which means that we could still ship our packages which would have the minimum weight, least weight, that would be between the range of 10 and 21. So what is the mid value of 10 and 21? We calculate the mid value. So 10 and 21 would be 31 by 2, that would be 15, right? We take the rounded value, so 15. And now we again perform the same evaluation. Okay, so we start calculating 1 plus 2, 3, 6, 10, and then 5, 15, and 5 plus 1, 6 would be greater than 15. So we found this value, and then next 6 plus 7 is equals to what is that? 6 plus 7 is equals to 13, right? So we get the next day. Then 8 plus 9 is greater than 15, so we just take this value for next day, and then 9 plus 10 is also greater than 15, right? So this would be package with weight 9 would be shipped in one day, and the remaining package of weight 10 would be shipped in the next day. So how many days are there? 5 days, right? So we got the 5 days, and the mid value is equals to 15. So this will be our final answer. So now let's try to code our solution. So we are going to perform a binary search. So we will need left pointer and the right pointer. And what's our left and right pointer? Left pointer is the maximum weight in this array, and the right pointer was the total weight, right? We started from value 55, and then we moved on with its middle value, right? And then we finally got this value 15. So we are going to take the final we are going to get for the left, and for right we are going to compute the values from our weights array. So left would be the max of the weight we have and the value left. So the maximum weight and right would be the sum of all the weights. Now what we'll do is we'll perform our binary operation, left less than right, and we will calculate our mid value. That would be the floor value, okay, of left plus right divide by 2. And then we also need two more variables, okay. All right, so this current would represent the sum that we were calculating, 1 plus 2 plus 3 and so on, and the days needed would represent the days that would need to carry these many weights with the minimum capacity of this much. And I have initialized it to 1, and now let's check. So what are we doing? We are looping over each of the values from the weights, right, after we have found our mid value. So okay, for loop, we are going to use the for loop for let weight of weights. So for each of the weight, we calculate the current value, that is, we add the weight, and if our weight is greater than our mid value, that is when we know that we need an extra day. So what are we going to do is we are going to increment our value for days needed by 1, and we are going to set the value of current to 0, because current in the code means these the addition of these weights. So we added all of these weights, and these weights are the sum of these are the current value, which should be maximum of 15. And then next day we start from 0, right? Our weight should be 6 plus 7, so the current should be set to 0, so that we add the values 6 and 7 to it, and it doesn't have any previous values stored in it. So now we have these two values, and then we check if the needed days is greater than days, which means that we need to shift more, the ship must have a more capacity than what we have right now, that is the mid. So since we need more capacity, we are going to shift towards the right, and the left would be mid plus 1, else we are going to shift towards the left, and that would be right equals to mid. And finally we are going to return the value of left, that would be the minimum weight of the ship. Let's run our code and look at the results. Okay, needed days, that's days needed. Oops. Okay, something went wrong with my code. Let's check. So left is max of all the weights, and right is the sum of all the weights. All right, so we perform a while loop. We find our mid with cursor current value 0 and days needed to. Okay, so we actually set it to the weight W. Why W? Because now we are evaluating, okay, because let me just give you an example here. So for capacity of 15, so what we do is we add 1 to 2, that's 3 plus 3, that's 6 plus 4, that is equals to 10 plus 5, that would be 15. And then while we are at this index with 6, we add this value 6, and that 6 is greater, that would be equals to 21, which is greater than 15, right? So what we did is we already have initialized 1, so now initialized one for this day is needed, right? So now what we did is, we know that now to ship this weight we need at least 1 day. So what we did is, we added 1 to our needed days, and then our current value now starts from this weight itself. So that's why we are assigning the weight to our current value, and then in the next iteration our weight is pointing at this value, and we add this to our current weight, and then when it's greater than 15, we then know that we will need an extra day to compute to ship this weight. So that is how we are actually making our code. So now let's run our code. Okay, let's submit it. Awesome. So we have solved this problem using binary search. So that would mean that the time complexity of this solution would be O of n, but since we are using a for loop and we are looping over each of the weight, right? So that would be O of n. So yeah, our time complexity is n log of n, and our space complexity is constant.